so what I wanted to do is do a urine review. Well, not really urine, but I guess urinary system review, because your book goes like back and forth, and I wanted to make sure that we put it all together. Is that okay? We can do that, and then whatever questions you guys have, various questions, then we can tackle those. Okay, so first thing I want to do, why don't we start with, okay, so PCT, proximal convoluted tubule. You know, there is 65% sodium, and this is also where you get 100% glucose. And sorry, I should put reabsorption is what I'm talking about. Reabsorption. Okay. Reabsorption. Okay, so 65% reabsorption of sodium, 100% reabsorption of glucose. And what wasn't made very clear is that you also have about 1% reabsorption of potassium, and they didn't really show that unless you go and look at figure 17.24, which I'm going to go over with you in just a minute. So we'll come back to that. Okay, so then you also will have Cl reabsorption because it follows sodium. And then something that we'll be talking about in our next chapter, the respiratory and acid-base lectures, we have reabsorption here, bicarbonate, and then we never really talk about this, but you also have some ammonium reabsorption, and then some protons. Okay, so that's everything that's reabsorbed in the proximal tubule. Okay, so now let's go ahead and look at potassium and everything. Actually, I'm going to draw. So you have images where it focuses on either like it's focusing on the sodium reabsorption or you know, one thing or another, and they never really show all of this reabsorption of potassium. So I want to put it all into one figure for you. Okay, so this is based on 17.24, but then I'm going to add on to it a little bit. Okay, so you have your tubule, and so we are looking at the proximal tubule. Okay, so filtrate is here, interstitial fluid is on the bottom, and then your blood capillary down here. Okay, and so I would say that the first thing that we would want to see, number one, would be the sodium and glucose. So why don't we go ahead and look at that? Sodium and glucose. So we're going to have glucose from the filtrate into the cell, and sodium from the filtrate into the tubule cell. And so this is number one. So if you look at that, is a coupled transport of sodium and glucose, which is also called secondary active transport. So you didn't use ATP here, right? So no ATP used here because it's used in step number 2. So this is number 1. So sloppy. Okay, number 2. Number 2 is the active, what we call, and I'll just write it up here. Oops, shoot. Maybe I'll change colors. Okay, so number 2, so number 2 is the primary active transport of sodium and potassium. This is your sodium potassium pump, okay? And so of course sodium's going to go this way, right, from the tubule cell into the interstitial fluid, and then it's going to go into the blood. And so this whole process of getting sodium from here to here is called reabsorption. In return, you're going to get potassium in opposite direction, okay? And of course, remember that this required ATP, and it gets used up. Okay, ATP gets used to transport sodium to the blood. Potassium will go in the opposite direction. The other thing shown in this picture would be, in fact, let's change colors. Step number 3 would be the glucose, and this is going to be facilitated diffusion because it's going to use a protein channel, but it's going to go out and then it's going to just directly diffuse into the blood. So glucose. And so we would say number 3, glucose diffuses out of tubule into blood. Okay, so the first step, it has to get through the basolateral membrane. It does that through a protein, but it is just diffusion, right? So facilitated diffusion. And then when it's in the interstitial fluid, it will just directly diffuse into the blood. Okay, next, this is the part that was not shown. Okay, so I'm going to say number 4, and this is our potassium. We actually have a lot of potassium, so I'm going to draw 2 arrows from the filtrate that diffuses into the tubule cell on its own, and then it also kind of running out of space here, but I'll just cram it in here. Okay, lots of potassium. Okay, so you get almost 100% reabsorption of potassium, right? So that's from the filtrate to the blood. You do get some going in the opposite direction from the sodium reabsorption process, but then it's going to, diffuse back out. And then some of it will stay. Most of it will diffuse back out. And furthermore, the most important part is that from the filtrate, the vast majority of the potassium that came from the glomerulus will diffuse through. And this is the part that was confusing you guys because it wasn't specifically shown in the picture or clearly written anywhere for you. So I wanted to make sure to clarify that. So this is in the proximal tubule. Any questions so far just for this part? Okay, so
Nope.
next, oh, yes? Okay, I'm gonna trust that we're ready to move on. So I'm going to say, now let's look at 17.15 in the ascending limb of the loop, right? So you have glomerulus, the proximal convoluted tubule, descending, ascending, distal tubule, collecting duct. So we're going to be looking here. Okay. So now this is, sorry. You have your cell, okay, and this is your ascending limb, the thick part, right? And number one is going to be a unique pump that does 1 potassium, 1 sodium, and 2 chloride. And that's here. Okay, so we'll have all going in the same direction. So this is a pump you've never seen before until here. And yeah, okay. And it's also secondary active transport. So no ATP here, it'll happen in the next step. And so then the next step, do a color. So number two, you're going to have ATP, right? And then that gives you ADP. And then you're going to have potassium and sodium. So this, number 2, is the regular sodium potassium pump that you're used to that takes ATP. So this would be your primary active transport. Okay, so the other part of number 2 is that Cl follows Na passively. And it does this, you know what, I need a little more space. So I'm gonna redraw. Oh shoot. Oh, let's see. There we go. There we go. Okay, just gonna draw this. Okay. And then I'm gonna go back to blue because we're still on step 2. Okay, so now we also have this little protein channel that allows some Cl to diffuse, but it also takes a little potassium. But then you also will have direct diffusion of calcium. And then I think what's not shown again is this, I would say is number 3, is potassium. So now this is going in the opposite direction. Okay, so in the ascending limb, most of the potassium diffuses back into the filtrate. Right, so most of the potassium that's coming in here, and that's also coming in here, most of that's gonna go back into the filtrate. You get a little bit that will go into the interstitial fluid, but most of it will go back into the filtrate. So I think that's everything I wanted to talk about, except for that's right. Okay, so then the last thing. Okay, so you recall that in the descending limb, there's only water reabsorption. Okay. And then in the ascending, that's what we just looked at. That's about 25% sodium reabsorption. Okay. And then in your distal convoluted tubule, you have about 10% sodium. And this is where you have hormones that can control fluid balance, right? So aldosterone will increase sodium reabsorption. And ANP, so atrial natriuretic peptide hormone factor. I don't know why there's 3 names for this thing. Sorry for that, but that's your book. Okay, so atrial natriuretic peptide or hormone, whatever you want to call it, is going to decrease the ability of sodium reabsorption. So you can do 2 things to decrease reabsorption of sodium. You can have less aldosterone and you can have more ANP. Okay, so both of those will, by decreasing aldosterone, you would decrease sodium reabsorption. If you have ANP, then you're also going to decrease sodium reabsorption. Okay, and then you have your collecting duct. And this, sodium, no sodium reabsorption, just water. And the hormone that can control this is ADH, antidiuretic hormone. So ADH is going to increase water reabsorption via making more aquaporins. Those little holes for water to go through. So if you increase ADH, you're going to absorb more water, and that means you'll have less urine. So I think that's everything for the review of urinary that I wanted to go over with you guys. I suggest that you go back through the lectures and make sure you understand it all, and then also review your PhysioX.